Have you ever looked at a crumbling bridge or a rusty old bike chain and just seen decay? Well, there's a really fascinating and powerful science hiding right there in plain sight. Today, we're going to unlock the secrets of electrochemical corrosion. Yeah, that's the invisible engine that's literally driving the world to rust. So here's our game plan for this explainer. First, we'll get to know our enemy, corrosion. Then we're going to dissect the anatomy of the attack, see the chemistry in action, watch how it plays out on everyday iron, and this is the best part, we'll figure out how we can actually fight back. You know, we usually think of rust as just this minor annoyance, right? Something to scrub off. But corrosion is a massive, massive global problem. It's this silent enemy that is just relentlessly attacking our infrastructure, our cars, and even our technology. To really get a handle on this, let's start with a question. What could a huge, decaying piece of steel and a tiny little power cell possibly have in common? Well, the answer is everything. You see, at its heart, corrosion is just an unwanted, short-circuited battery. And once you get that one simple idea, everything else just clicks into place. Okay, so if corrosion is a battery, what are its parts? Well, for this electrochemical battle to even start, you need 4 key players on the field. So let's meet the team that forms what scientists call a corrosion cell. First up, we have the anode. This is ground zero for the attack. Think of it as the part of the metal that sacrifices itself for the team, you could say. It literally dissolves, releasing a flow of these tiny charged particles, electrons, into the system. Now, every anode needs a partner, and that's the cathode. So while the anode is busy dissolving away, the cathode is kind of like the safe zone. It's the part of the metal that accepts that steady stream of electrons coming from the anode, and because of that, it stays protected from the corrosion. Of course, these two parts need a way to connect, right? And that's the job of the electrolyte. Now, this is just a fancy word for a liquid that can conduct electricity. And most of the time, we're just talking about plain old water, especially if it has a little salt in it. It's the highway that lets charged ions travel between the anode and the cathode. And the final piece of this puzzle? It's the metallic path. And this one's super easy. It's the metal itself. The object provides a perfect built-in wire for those electrons to race from the anode, where they were let go, all the way to the cathode, their final destination. And there you have it, the whole shebang. With all 4 players on the field, you've created a complete electrical circuit right on the surface of the metal. You've got a source, a destination, an ion highway, and an electron wire. You've just built a tiny, powerful, and incredibly destructive battery. So we've met the players, but what are they actually doing on the field? What's the play-by-play? Well, it all comes down to a microscopic exchange of particles. This is the real chemical warfare happening here. And here's the heart of the reaction. It's actually a 2-part process happening at the exact same time. Over at the anode, you have a process called oxidation. That's just the scientific way of saying the metal loses electrons. And at the exact same moment, over at the cathode, the opposite happens, reduction, which means it gains those very same electrons. It's a perfect exchange. One can't happen without the other. Okay, theory is great and all, but let's make this real. Let's look at the most famous example there is. We're going to see how this tiny micro battery gets to work on a simple piece of iron, creating that rust we see every single day. So picture this. A single drop of water lands on an iron nail. That water is our electrolyte. Now, right in the middle of that drop, where there's a little less oxygen, an anode forms and the iron starts to dissolve. But at the edge of the drop, where there's plenty of oxygen, a perfect cathode forms. So electrons zip through the nail from the center to the edge. Ions move through the water, and the final result of that reaction is iron oxide, that flaky reddish-brown stuff we all know as rust. So here's the cool part. Knowing that corrosion is just this 4-part battery, well, that gives us the key to defeating it. The entire science of preventing corrosion comes down to one simple idea. You just have to break the circuit. And here's how we do it. We can fight back in a bunch of clever ways. The most common is probably a barrier coating, like paint. It's simple, right? It just keeps the electrolyte, the water, off the metal. Done. We can also choose better materials, like stainless steel, which are just naturally less willing to be an anode. We can also just control the environment, keep things clean and dry, and you take away the electrolyte. Or, and this is my favorite, we can use a sacrificial anode. You actually attach a different, more reactive metal that corrodes on purpose, sacrificing itself to protect the more important structure. How smart is that? This quote really puts everything into a totally new light. We see corrosion as destruction, but from a chemical point of view, it's really just nature trying to return these refined metals back to their original, more stable, natural state. So it's not really an attack, it's a powerful fundamental force of nature. So, if this invisible electrochemical engine is constantly trying to unmake the world that we've built, it kind of makes you wonder, doesn't it? What other unseen forces, what other invisible processes are constantly shaping and reshaping the world all around us every single day? Something to think about.